If you are working in the field of AI or machine learning, then definitely you must have heard of this term transfer learning. Why it is popular and why so many people want to learn about it. And the meaning is quite clear from the term itself that you can transfer the learning of a particular model from one application area to another application area. And that's the whole beauty in that you don't need to do the whole process again. You just need to transfer the learning. So we'll see that what this topic is all about and how specifically you are going to get all the basic related information and from where. So the term transfer learning is a kind of means if we talk from research point of view, it's a kind of domain where the people use different machine learning based techniques and they use the stored knowledge or the gained knowledge from one particular problem domain and they apply that particular knowledge into the second domain. So in this way, you transfer the learning earned from one problem that you solved and then you are applying it into another problem. So in this way, you can say that transfer learning is going to get worked. But the only thing that the both problems or the both domains from where you are taking the knowledge and from where you are to where you are applying, both should be kind of correlated. Because if they are totally different in nature, then obviously you are not in a position to apply this uh, transfer learning concept. Okay, because it's not necessarily that one domain knowledge gets applied to another domain knowledge. So let's start with the again our research papers and details. So this is a Springer survey paper where they have talked about specifically about transfer learning. A Journal of Big Data published it in 2016. So there you'll find a lot of real world applications based different techniques related to machine learning as well as the discussion of big data, how the big data is a kind of big problem and how you can effectively apply the different sorts of machine learning techniques to solve big data problems, and then how you can apply those techniques or the knowledge gained from one type of domain and you can transfer it to another domain. All these things are going to get covered here. So you will get all the basic understandings of the transfer learning and the related concepts. What are the sort of current solutions where you can transfer these sort of applications and actively different reviewers point, because reviewers point means the author's point in the terms of different reviewers, because when you are a author you are seeing all the existing literature as a reviewer, and then you are making a short or the concise form of the existing literature and putting forward for the next reviewers, means the readers of your paper. So similar way, they have covered the background over here, including the data mining and machine learning related fields. And then they focused on to the transfer learning. Then they jumped onto the different sorts of techniques or the devices where the people apply these sort of things of transfer learning. Then which sort of tools and techniques are used for a specific application of transfer learning? What sort of different domains which are related to this domain of transfer learning? And mathematically, how you define the kind of definition of transfer learning, means how you form the mathematical model of transfer learning, because ultimately the machine learning or the AI field, everything is at the back end is totally in mathematics, because you are forming the different sorts of models, and those models are different sorts of models, and those models are working on some sort of means mathematical structures, and those structures are giving or the actually boosting the main power of AI or the machine learning. So ultimately, how efficiently you apply different sorts of mathematical concepts, or how efficiently you correlate or convert the real world phenomena into mathematical forms, and then you just feed them to your actual processor or GPU, then that's the power that is coming to, and which is fueling the deep learning. So whole sort of process is available over there. A lot of mathematics is there in the background of AI and deep learning. So you should be good in these terms. At least you should have a basic understanding of the mathematical modeling, that how the mathematical models are formed, or how to convert the real life scenario based situations into the mathematical form equations, and then how you can correlate those equations, how you can define the optimization functions or something like that, and then how to create the different sorts of output and like that. So in this way you can efficiently understand the whole process, even if it is presented in mathematical terms. Okay, then moving down and down, you will find the different types of transfer learning, and then you will find the different authors specific overview on the existing techniques which are relating to these different classifications of transfer learning. Now, specifically, when people are coming to this particular domain, then neural networks comes as a focus, and neural networks guide the different sorts of application area that are under focus, because neural networks are specifically used for different application areas for which they are bit optimized or better suitable. And people use means the authors use specific types of neural networks for a specific type of problem solving. So that's why it means you need to be very much cautious. You should have some background knowledge. You should have the kind of application as well as the challenges as well as the future scopes with respect to any model or the kind of network that you are choosing for your problem solving. So in this way, you can see that lots of details is available over here. Just jump onto it. You will find the basic definition, then homogeneous, heterogeneous, negative transfer, then the transfer learning applications, finally the conclusion, references, and all the related. Some of the appendices are also provided over down here. Okay, so in this way, this is the kind of survey I'm recommending you. Still, there are more surveys which are related. It is 2016 work. You can find it 2022 or 23 work, which are more relevant because there are number of new works which have come after 16. So obviously, so many different works have also been added up in the domain of transfer learning. But main point is that whenever you are going for a specific type of work or a specific type of paper, always see that what scope it is covering, what is the dimension, what is the breadth it is covering, and then means if you are a basic or the beginner, you should cover breadth, and if you are a kind of pro, then you should cover the depth. That's the whole funda. And hopefully, you know the basics of research, so you can do it well from your point of view. Now, that is from this particular paper. Coming back to the specific details of transfer learning. So, transfer learning says, as I told you, that it's a machine learning technique where the models are trained from one task and then the acquired knowledge gets applied to another domain or the task. So you are what you are doing, you are just leveraging the knowledge power, because ultimately you are gaining the knowledge from one domain and you are just transferring to the domain. But specifically, when we are saying that both domains or the problems should be correlated, then there must be some difference between these problems. Otherwise, why you are transferring the knowledge? If both are same, then there is no problem at all. So if you are transferring the knowledge, means there is a bit difference between both problems or the domains. Then what is that difference? How your knowledge is going to get changed? Because exactly you are transferring there, it is not always the case. Many times you need to make bit changes, and it depends on the type of differences that the both domains or the problems are having. Okay, you need to be extra careful in some of the situations where the limited data is available, means the data size is not proper according to the specific prerequisites or the requirements based on the problem. For example, in deep learning, you need to have good sized data set. It is not like machine learning where the short data sets are going to work. Additionally, at what level you are working? You are working at a scratch level, you are working at intermediate level, or what? All these things also matter. So you need to see that what sort of application area you are focusing. Additionally, what sort of current data set state you are having, what sort of techniques you are applying, and what sort of knowledge you are having from the earlier domain. Now coming to the dataset details, so number of data sets are available with respect to transfer learning, and some of the common ones include the Office Home, MFRC, standing for the Moral Foundations Reddit corpus, and you have the SIM for actions. Um, Particularly, it is not SIM for action; it is SIMS for action. You have the Kitty, and we have also covered the Kitty in our database series, so you can go and have a look at Kitty over there. Then you have the retinal fundus multi-disease image dataset. In short, it is RFMID. And then coming to the specific works that you can do on these datasets, then you can go for the auxiliary learning. You can do the transfer reinforcement learning. You can do the unsupervised domain expansions, etc. So these are some of the different things and they can perform with respect to transfer learning. And coming to the number of works, so multiple works are there, not as many as in comparison to the normal means other works in the field of deep learning or ML. but still multiple works are available over there. And some of the related works, including the high quality molecular depth estimation via transfer learning, is one work, which is whose repository is also available on GitHub, and it's a TensorFlow implementation, a 2018 work. Okay. Then another one is exploring the limits of transfer learning with the unified text-to-text transformer. So you can see that here the natural language processing comes into picture, and you are applying the transfer learning for the natural language processing, and it's active exploration. It is again a TensorFlow implementation, and the GitHub repository is available. It's available on our side in the form of 2019 work. Then coming to the specific work where you are having the sentence encoder. So universal sentence encoder is a work which is a PyTorch implementation, and it is again available at GitHub, where you can go and have the sort of actual hands-on sort of thing available. Then if you are interested into the specific transfer learning work, then the transfer transform is a work which is available in the PyTorch form, and it is available at GitHub, which is in particular a transfer learning based approach for neural network based conversational agents. Okay, so you can see that based on the key terms that you are finding into a specific work, that it should be a kind of conversational means NLP based work, it should be a neural networks based work, it should be a transfer learning based work. So all these key terms are important. Whenever you are trying to find the papers, always go for these key terms, and this will help you to filter out the additional works and specifically make you to focus on the specific area which you are targeting. Okay, so that's all from my side for this particular video. Hopefully at least some of the related helps must have been there. There are a number of more papers. I'm not quoting all of, I'm just quoting some of which are available at Google Scholar, so you can go and have a check for more papers. Hopefully it will be useful for you. Thanks for watching. Happy learning.